Now we're ready for the last example. This one involves baseball. A baseball is hit from home plate with a 40-degree angle to the horizontal and a speed of 44 meters per second. The ball is hit in direct line with the center fielder, who's 140 meters away from the batter. With what average velocity should the center fielder run in order to catch the ball at the same height from which it was hit? Boy, what a problem this is. I'm going to tend to want to sketch a side view of this, but there are several things that occur to me. First of all, which way is the center fielder going to have to run? Is he going to have to run toward the batter in order to catch the ball? In other words, the ball is hit short and the center fielder has to run towards the infield. Or is the ball hit too hard for where the center fielder is standing and the fielder must run backwards in order to catch the ball closer to the fence? I don't know that until I figure out what the range of the ball is. So it occurs to me that what I want to do is to figure out how far the ball would go and then figure out where that is with respect to where the center fielder is, and then figure out what distance there is between the center fielder and the ball when the ball is hit and where the ball is going to land, and then to figure out how much time the center fielder has to cover that distance, and then take that distance divided by the time, and that's going to be the speed with which the center fielder is going to have to run. The velocity is either going to be toward the batter or away from the batter, depending on what the direction is. So that's kind of an outline of how I propose to approach this problem. So let's focus on the ball at first, and let's write down information we know about the ball. Let's break the initial velocity of the baseball into horizontal and vertical components. I find that the ball starts horizontally at 33.7 meters per second and vertically at 28.3 meters per second. Now what? Well, the ball is going to have a trajectory, a parabolic trajectory, and it's going to take a certain amount of time to hit the ground, or a certain amount of time to reach the fielder's glove, which is at the same level that the ball was hit from. If we say that the ball leaves from the same level that it returns, then the y and y naught for the ball are going to both be 0. Vertically, the ball is in free fall motion, so it has an acceleration of negative 10 meters per second squared. I can use the second equation of motion. Y is y naught plus v naught yt plus 1/2 ayt squared, and solve for t. Once I've got that t, I can put it into the horizontal equation to figure out where the ball is going to be horizontally from where it was released. Since the starting and ending position are equal to 0, then I can put those in, and I can factor that equation. And now this equation will be solved if t is equal to 0, or if the stuff in parentheses is equal to 0. Well, t equals 0 is not very interesting to me, so I'm going to set the stuff in the parentheses equal to 0 and figure out what t is. Solving that for t, I get a certain expression that I can put numbers into. I find that the amount of time that the ball is in the air until it reaches the same level that it left from is 5.66 seconds. How far did the ball travel horizontally in that time? Let's take that 5.66 seconds and plug it in to the horizontal equation of motion. The initial position is at the origin, and the acceleration in the x direction is also 0. Let me make those substitutions, and now we put in the numbers. I get that the ball is going to land almost 191 meters away from where it was struck. In other words, the distance between where the ball leaves the bat and where the ball is going to reach that same vertical level is 191 meters. Now what? Well, I was told in the original problem that the outfielder is standing at 140 meters away from home plate when the ball is hit. So the center fielder has got to cover 51 meters and has to run away from home plate, away from the batter, in order to catch the ball. How much time does the player have to do that? Well, the player has the same amount of time that the ball's in the air, 5.66 seconds. So if the center fielder has 5.66 seconds to cover 51 meters, what's the center fielder's average speed, average velocity going to be? The average velocity is going to be the distance covered divided by the amount of time to cover that distance. Let's calculate that. I get that the center fielder has to run at an average speed of 8.95 meters per second and has to run in a direction that's away from the batter. So the velocity for the center fielder to make the play is nearly 9 meters per second away from the batter. Let's review just briefly what we've seen. When I deal with advanced kinematic problems, generally there are going to be two or more things that are in motion at the same time. Those objects are going to have something in common, and the approach that I take to solving these problems is going to be to sketch a good diagram to figure out what it is that the question's asking me, and then to apply the appropriate equations of motion for each of the objects until I can find what it is that the objects have in common, and then answer the question based on that. There's no set way to go about these problems. You have to think your way through them all. And so you've got to have a cool head and a good understanding of what's going on, plus be able to bring your physics to bear to solve these problems. So for now, that's it.